There are a few different ways that plates can interact with each other when they're next to each other. And so this will be just a quick summary of those ways to interact and some of the landforms that are created. We're going to have three big categories of interactions. One will be when the pieces of crust, the tectonic plates, are moving toward each other, and that's called a convergent boundary. Another is when they are moving away from each other, and that would be a divergent boundary. And the last one is when they're moving parallel to each other, and that one is a transform fault boundary. Okay. So of these three types, we've actually dealt already with examples of convergent and divergent boundaries. The first one we talked about for divergent boundaries was one where we had a piece of oceanic crust moving away from another piece of oceanic crust. And the effect of that, when they spread apart from each other, there's mantle underneath, which is very hot but solid while it's under lots of pressure. When they spread apart, though, that gap releases a lot of that pressure, and part of the mantle will melt and get squeezed out the opening. So now these are a little further over, and suddenly we have kind of a blob of magma down here, melted mantle. And that magma gets pushed out through that opening, and it'll pile up on the sides, and it makes sort of a slope on the two sides here. There we go. And then kind of a dip in the middle. So it will kind of look like an underwater volcano then. This is the bumps over on the sides here are what we call mid-ocean ridges. And it was the discovery of those mid-ocean ridges that helped us understand how the continents could be moving around. They don't actually have to go through the oceanic crust. The oceanic crust is actually changing shape and size over time. We also talked about a convergent plate boundary. That was when a piece of oceanic crust meets a piece of continental crust. And it's important that continental crust is thicker than oceanic, and that oceanic crust is denser than continental. So when the two of those meet, feeling like this is not very well distinguished over here. There we go. So when the two of these meet, since the oceanic crust is denser and thinner, it's going to tend to get pushed underneath the continental crust. And so our next phase will have kind of this push down of the oceanic crust underneath the continental crust. That's called subducting under the continental crust. And then this deep area right here is known as a deep sea trench. Now, there are a couple other landforms that we see as a result of these two plate boundaries. We've talked a little bit about this next one, when two pieces of continental crust are moving toward each other. Just abbreviate that, C-O-N-T, continental. Since neither of them is denser than the other, they don't tend to have one go under and one go on top. Instead, it's a messier collision. We see kind of a crinkling up of these two things as they crash into each other. Right now, India is crashing into the Eurasian continent, and the result of that is a giant crinkling that we call the Himalayan mountains. And so what we'll see on the surface is this kind of a shape. This is the border between these two. And actually underneath the surface, we would get some of the same effects. I'm pushing down further than it had been as well. We just can't see it because it's way underground. But if you could like make the mantle clear and you could see through, you could go into the mantle and look up, you'd see these mountain ranges that are poking down from the surface. So just sort of an upside down mountain range there. And so this is a mountain range being formed when two continental crust pieces meet. And then back over to the divergent boundaries, our second type here that we'll be responsible for knowing is when two continental crust pieces are moving away from each other. For this one, you ought to think silly putty. When you stretch out two pieces of silly putty, the part in the middle, it gets longer, but it also gets thinner, and it kind of hangs down in the middle, it sags in the middle. And so what we ought to expect to see there is something like this. And then this area in the middle is known as a rift valley. And sometimes that rift valley gets deep enough, it actually gets lower than sea level, and nearby oceans will drain into it. And so we can actually get this thing filled with water. It doesn't have to be, but at some point it gets filled up with water, and then that water is a sea. So oceans have oceanic crust at the bottom of them. Seas have continental crust at the bottom of them, and as a result, they're much shallower than oceans. At some point in the distant future, these two pieces, just like that silly putty, if you keep stretching it out, eventually it just breaks, and we have two separate pieces moving away from each other. Then it starts to look more like this, where we have that break, and magma can enter through that break and fill in the gaps. We're going to have a development of oceanic crust at that point. So in the middle here, when that breaks, it gets filled in with oceanic crust, and now we have the starts of a new ocean. As for the transform fault boundaries, we didn't get too far into those today, but these are going to be side-to-side motion. Namely, what we're going to see is what we call a transform fault line. Which is just going to look like a giant crack in the ground. And we're going to see some shifting over of land features. Not sure why I'm indenting all of this. So if we imagine this is like a top-down view now, and here's a transform fault type boundary. We could have, say, a river wiggling its way through, and it crosses over that transform fault boundary. When that transform fault boundary slips, it shifts side to side, at some point in the future, what we're going to see is, well, I guess we can imagine this part of the plate coming up here and this part being down here. So now we have a shift. So this one has moved this direction, this one's moved this direction. Indicate that up here. And now we have our river getting shifted as well. So we have this very sharp turn in the river along the riverbank. And that is a transform fault boundary. The one that you're probably familiar with in the U.S. is the San Andreas Fault. And the big thing we find there is that it's not a gradual shift on these ones. It's a lot of start and stop motions. They call it stick-slip motions. It sticks for a while, and then it slips, and then it sticks, and then it slips, and then it sticks, and then it slips. And whenever it slips, we feel it as an earthquake. So those are the main landforms that you're responsible for knowing related to tectonic plate movements.